Number 1, tickets to a family concert cost $10 for adults and $3 for children. The concert organizers collect a total of $900 from ticket sales. In this situation, what is the meaning of each variable in the equation? So if we take a look at this equation, when it says 10 times A, so we see the $10 in the paragraph, and it goes with the number of adult tickets. So A is the number of adult tickets sold. And then when we look at the equation for C, C has a 3 in front of it, and we see the 3 in our paragraph, and that goes with the children's tickets. So C is the number of children's tickets. B, if 42 adults were at the concert, how many children attended? So we're going to be able to figure out how much money or revenue we took in from the adult tickets by doing 42 times 10. So $10 per adult ticket. And that gets us a revenue of $420. And we know that we took in $900 total. So if we subtract 420 from 900, then that will give us the amount of revenue we took in for the children's tickets. So 900 minus 420 is 480. And then every children's ticket cost $3. So we can divide this by 3 to figure out the number of children's tickets is 160, which would be the same as the number of children that attended. Part C gives us that 140 children went to the concert, and then they want to know how many adults. So this time we can take 140 times 3, since that's the number of children's tickets, and that gives us $420 in revenue. So then again, we'll subtract that from our total revenue and get 480. And then we want to take that and divide it by 10 now, since we're looking for the adults. So 480 divided by 10 means that 48 adults were in attendance. D, write an equation to represent C as a function of A. Explain what this function tells us. So we're going to take this equation and we're going to solve it for C. So I have 10A plus 3C equals 900. So we're going to subtract 10A from both sides, just like we did here, okay, but we did it with an actual value plugged in. So that's going to give us 3C equals 900 minus whatever our adult revenue was. And then to solve for C, then we just take that number and we divide it by 3. So then our C equation is equal to 900 minus 10A and then divided by 3. And this would represent the number of children's tickets. So this would just be solved for children's tickets. Then we'll take the same equation and we'll solve it for A. So now we're going to take and subtract the children's revenue from both sides, so that we're down to just the adult revenue. So 10 times the adult tickets equals our total revenue 900 minus our children's tickets revenue. And then we can divide by 10 to get down to our adult tickets. So then this one is just solved for adult tickets. This one is solved for children's tickets. Number 2, a school group has $600 to spend on t-shirts. The group is buying from a store that gave them a $5 discount off the regular price per shirt. N equals 600 divided by P minus 5 gives the number of shirts that can be purchased at regular price. And then P equals 600 divided by N plus 5 gives the regular price of a shirt when N are bought. So what is N when P is 20? So in this one, we're solving for N. We want to know N. So we want to use the equation that has N solved for. So we would say that N equals 600 and then divided by 20 minus 5. So 600 divided by 15, and 600 divided by 15 is 40. So then we know that we have 40 shirts. So N is the number of shirts. And then what is P when N is 40? So when N is 40, what's P? Well, we just figured out that N is 40 when P is 20, right? So it should give us back this. So we'll go to the equation where P is solved for and we'll plug in 40. So P equals 600 divided by 40, and then we're going to add 5. So we'll first do the division, correct? Because order of operations would tell us division first. So 600 divided by 40 is 15. And then we'll add that 5 and we get 20. 20 is the regular price. So $20. So that represents the regular price. And then is one function the inverse of the other? Explain how you know. Well, yes, because when we flip-flopped these, right? So when I plugged in 20, I got back 40. And then when I plugged in 40, I got back 20. So when I plugged 20 into the one, it gave me 40. So then I plugged that into the other equation and it gave me back 20. So that just means that they're reverse operations, which means that it's an inverse. You could also solve these for the other variable. Like you could solve one of them for, like if I solved this one for P, it should give me this equation. And that's another way you can tell that they're inverses if you wanted to do that. Number 3, F and G are inverses. If F of negative 2 equals 3, is the point 3, negative 2 on the graph of F, the graph of G, or neither? So remember when it's written in this form that the number inside of your function is your X value and the number outside of your function is your Y value. So we know that this point is on F. Okay, so this point is on F. And now we need to compare it to this other point that they asked us, 3, negative 2. And this one is actually going to be on the inverse of F. And we know that because these values switched places. So that the Y became the X and the X became the Y. So X, Y flipped or switched places is probably a better way to say that. And so if we know this, so we know that it's on the inverse, we know that it's on the inverse of F, and we know that G is the inverse of F, so we know that this point is on G. Number 4, here are two equations that relate to quantities P and Q. So Q equals 7P plus 1,999. P equals Q minus 1,999 divided by 7. Select all statements that are true about P and Q. So A says Q equals 7P plus 1,999 could represent a function, but P equals Q minus 1,999 could not. And that's not true. Both are functions. So both are functions. So that's false. B, each equation could represent a function. Yes. C, P equals Q minus 1,999 over 7 could represent a function, but the other one could not. No, we just said both of them are. Okay, all of them are in B, so that means those are false. The two equations represent two functions that are inverses of each other. Okay, so are these reverse of each other? So let's just solve this one over here quick for Q. Because if we solve this one for Q and it gets us this same equation, that means they're inverses. So I'm going to multiply both sides by 7. So I'd get 7P equals Q minus 1,999. So then to get Q by itself, I'm going to add 1,999 to both sides. So I get 7P plus 1,999 equals Q plus 0, right? So this is all 0. So then we end up with this equation, which is the same as this. So that means that, yes, they are inverses of each other. If Q equals 7P plus 1,999 represents a function, then the inverse function can be defined by this, and that's false because we just looked at that this is the inverse. So this one is not the inverse. Number 5, Elena plays the piano for 30 minutes a day, each practice day. The total number of minutes, P, that Elena practiced last week is a function of N, the number of practice days. So we've got P is the total minutes, N is the practice days last week. So what's the domain and what's the range? So P is a function of N. So N is our input. And N represents the number of practice days. Okay, so this is the number of practice days. So I'm just going to write it out in words. And then, so what could that be? Well, we're talking last week. Okay, and so last week only has 7 days. So this is going to be the whole numbers 1 through 7. Well, actually 0 through 7. She could have practiced 0 days. So she didn't practice at all. She practiced 1, 2, 3, 4, 5, 6, or 7 days. That's it. And then the range is going to be your output. Okay. In this case, it's going to be the total number of minutes. And so what could that be? Well, this says that each time she practices, it's 30 minutes. So she's not practicing for any other chunk of time. So it's just 30 minutes or she doesn't practice. So if she practiced 0 days, she'd have 0 minutes. 1 day, she'd have 30. 2 days, she'd have 60, 90, 120, 150, 180. Or if she practiced all 7 days, she'd be at 210. So domain is just going to be whole numbers 0 to 7, and range is going to be multiples of 30 from 0 to 210. Number 6, the graph shows the attendance at a sports game as a function of time in minutes. So let's describe how the attendance changed over time. So we can look here and we can see that it's, the attendance is really quick in the beginning, right? A lot of people are coming in the first 10 minutes. Let me make this a little smaller here so it fits. All right, so there's a lot of people coming in the first 10 minutes. Okay, then it slows down, right? But still people are coming. Okay, so then it slows down for about 5 minutes. Then no one enters or leaves for that flat part, right? So like right here, then nobody else is coming in or leaving for, what do we got? This is probably at like 15 minutes to maybe like 45. So for about 30 minutes. Then a few people leave. Then no one leaves when it flattens out again. Then everyone leaves pretty quickly, rapidly for the last about, okay, so right here you've got quite a few people leaving. That's maybe at like 55 to 70, so like in the last 15 minutes. Okay, then everyone leaves rapidly for the last 15 minutes. So you don't have to have the same description as me, but just something similar to that about how you have, you know, a lot of people coming in at the start. It levels out a little bit, but still people are coming in. Then nobody's coming in. Then a few people leave, nobody leaves or enters. And then, you know, at the end of the game, everybody's leaving pretty quickly. Describe the domain. So the domain is the minutes, right? So the domain is all numbers or all values between 0 and 70. Okay, and we can have partial minutes. So that's why it's all values, not just integers or whole numbers. And then the range is the number of people. So this is whole numbers, because you can't have half a person. So whole numbers between 0 and looks like it doesn't quite get to 60. So maybe like 55. Number 7, 2 children set up a lemonade stand in their front yard. They charge $1 for every cup. They sell a total of 15 cups of lemonade. The amount of money that the children earned, R dollars, is a function of the number of cups they sold, N. So if I wrote that out in function notation, it'd be R of N. Is 20 part of the domain? So N is the domain, okay, and that's the number of cups they sold, right? So N is the number of cups. Is 20 part of that? And that would be no, because they only sold 15. What does the range of this function represent? So what does the R represent? And that's the dollars that they earned, right? So it's their, you know, the money they made. Which you could also say their revenue. Okay, so revenue is how much money they bring in. Describe the set of values in the range. So the money that they're getting is $1 per cup, and they sold 15 cups. So they, you know, the range would be as they're selling it, they had $0, okay, all the way up to 15, and then it's just going to be whole numbers. So they're not going to get partial dollars because they're not selling partial cups. And so is the graph of the function discrete or continuous? Explain your reasoning. So this is going to be discrete because of what we just said here, that they're not selling any partial cups. So discrete because there's no fractional cups. So you're just going to sell 1 cup, make $1. So if we were looking at a graph, if you sell 0 cups, it's $0. 1 cup, $1. 2 cups, $2. 3 cups, $3. 4 cups, $4, and so on. But you're not going to connect this because you're not going to sell half of a cup and make 50 cents. You're not going to sell 1.5 cups and make $1.50. It's just these whole number values. Number 8, here's the graph of a function which represents Andre's distance from his bicycle as he walked in the park. Estimate f of 5. So let's take a look here. So f of 5, so this is your x value, okay, or your seconds value. So at 5 seconds, so follow that up to the graph, and then what's the output? So in this case, 5 seconds gives us 5 feet away. So the output of that one is 5. Estimate f of 17. So if we go over, so 15, 16, so here's 17. And if we go over, the output is 1. So then he's, after 17 seconds, he is 1 foot away from his bike. Then for what values does f of t equal 8? So now our output is 8. So we want to go to the output, kind of draw that line across and see where it crosses the graph and find all of those x values. So we see it crossing here, 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 and here. So it's got 4 different values where he's 8 feet away. So he's 8 feet away after about 8.5 seconds, after about 9.5 seconds, after 20.5 seconds, and then after 22 seconds. So all of those, he is about 8 feet away from his bike. For what value does f of t equal 6.5? So let's take a look. So now we know that when are we 6.5 feet away? So we'll go here. And then we'll look at these values. So we've got this one. Okay, then this is kind of, we've got this whole chunk here actually, okay, all the way up to here, because that was flat line. So this whole chunk of the graph is at 6.5. And then we have this one and we have this one. So he is 6.5 feet away at like 6.5 seconds or 6-ish seconds. Then at from 11 to like 14.5. So all the way from 11 to 14.5. So I'm just going to write when the time is between 11 and 14.5 seconds. So when 11 is less than or equal to t, which is less than or equal to 14.5. Then again here at 19.5. And then what's this one? 21, 22, 23.5. And then when does f of t equal 10? So here's 10. So when does it equal 10? Never. Okay, it never touches that. So he's never 10 feet away from his bike.